Welcome to the third lecture on statistical methods in high-energy physics. A very important tool in statistics, particle physics, and many other fields are various Monte Carlo methods. Monte Carlo is a powerful tool for approximate calculations of problems that are difficult to solve analytically. One of the method's father is Stanislav Ulam, who worked in the late 1940s in Los Alamos on the Manhattan Project. Its name refers to the Monte Carlo casino in Monaco, where Ulam's uncle would borrow money from relatives to gamble. Nowadays, the name Monte Carlo stands for anything that uses random number generators to solve some specific problems. A very common use of the Monte Carlo generator is numerical integration. Another one is generation of draws from any given PDF, the so-called pseudodata. There are many algorithms to generate uniform distributions. The root generator class is called trandom3. Usually, numbers in the range between 0 and 1 are generated. U is distributed according to uniform distribution between 0 and 1. Let's now describe how to generate random numbers according to any given probability density function, provided that we have a generator of the uniform distribution. There are several ways, but the most straightforward one is definitely the one based on inversion of the cumulative distribution function. We want x distributed according to the probability density function f, and let's assume we can construct inverse to the cumulative distribution function, inverse to the capital F. If U is distributed according to the uniform distribution, then x, defined as an inverse to the cumulative distribution function of U, is distributed according to the probability density function f. For the proof, it's enough to realize that the cumulative distribution function F, if considered as a random variable, is uniformly distributed as we have shown previously. If x is distributed according to f, then numbers F of x are distributed according to the uniform distribution. Therefore, if in turn U is distributed according to the uniform distribution, then the numbers of inverse of F of U must be distributed according to the original function f. Another method for generating draws from any probability density function is the accept-reject method. We can use it if we are unable to construct inverse of the cumulative distribution function. First, we need to find some function g that is always larger than our probability density function f. For example, g can be the supremum of f. Then, we start generating pairs of two uniformly distributed random numbers. The first one, x, is drawn from the uniform distribution on an interval x-min to x-max. The second one, u, is drawn from the uniform distribution on an interval 0 to g of x. If u is less or equal to f of x, then we can accept the value of x into a random sample. Otherwise, we reject it. The x values filtered this way follow the distribution f of x. Note that the root class trandom3 can generate many predefined distributions, normal, Poisson, etc. And in roofit, one can generate any probability density function. In root, there are many random generators. Trandom3 is a good choice because it's quite fast and has sufficiently long period for most use cases. Make sure that you do not use the generator implemented in the class trandom, as it has a too short a period for all but the most simple applications.